Yeah, so on this one, principles of equality, and again, right here, we couldn't use the same trick we used on that last one where I'm just gonna divide both sides by 3. I mean, you could, just you have to be very careful doing that. So I'm not recommending, okay? But this one here on the left, let's go and solve it, and I will use distribution. I know some of you know that you don't have to, but you could, I'm going to, okay? So I'm gonna distribute my 3 into the x minus 3, so that'd be 3 x's, and then 3 times negative 3 is negative 9. Nothing else really changed right there. So some technology here. But now I do have some like terms to combine. Negative 9 and positive 12 would give us positive 3. So now it's 3x plus 3 is greater than or equal to 18. So subtract 3 from both sides. To zero that out, drop your 3x greater than or equal to 15. And 15 is a multiple of 3, so it's going to turn out very nice. Divide both sides by 3. X is greater than or equal to 5. Okay, so there's our first one. And we have this other one as well on the right. So we'll do this one in purple. 2 principles of equality in 1. I'll put the x's on the left because I have more on the left and then the numbers on the right. So minus 6 from both sides to zero that out. 2 minus 6 would be negative 4. And then I'd have to subtract 4 x's from both sides as well. That'd give me 1x. And remember, the idea with the last step in solving equations or inequalities is to get the coefficient to be a 1. So I'm just going to make that a phantom 1. So that's it right there. That is the inequality for that, I guess, overall inequality. Okay. Now again, before I put an and statement, let's see what the graph looks like. So here's 0, negative 4 on the left, and then 5 here on the right. I'll start with the red one. X is greater than or equal to 5, so that's a closed circle of 5 going to the right because it's eating the x. And then a negative 4 open circle, this one's not eating the x, so it goes to the left. Now again, for an or statement, this would be good, but this is an and statement. So is there any indication on this graph that it would be true for both? No, because the lines don't intersect. So, you know, I'm just going to put a big DNE on this one because it's the empty set, right? This doesn't have any solutions that would be true for both. I don't think that's super tricky, but, you know, it can throw us off sometimes because it's like, well, they don't intersect, so it has to be an or statement, right? No, don't get caught up in that. You have to think of this in terms of the and. If you really understand that, then you know pretty quick that that's a DNE, which also makes solving this go a little bit faster, too.